Now we're moving beyond local AI agent demos and into production. Reliable Web3 apps need clear boundaries around APIs, workers, schedules, webhooks, storage, and protected secrets. The goal is simple: autonomous blockchain operations that are secure, maintainable, and ready for real users. You've already moved from core agent reasoning to real blockchain interaction to production concerns like security, observability, audits, and testing. Now we'll turn that foundation into deployable services. Local agents can work as scripts because the operator is nearby and failures are easy to see. Production removes that safety net. User-facing requests need to be separated from background automation with controlled access, persistent state, and audit trails for each path. Wallets and signing become protected infrastructure, not helper functions. Every on-chain action should be designed for retries, timeouts, RPC outages, reorgs, and partial failures, so the agent can be monitored, scaled, and recovered safely. In AI plus Web3 apps, keep the user experience separate from the systems that make decisions and sign transactions. The frontend collects intent and asks for confirmation. The backend validates requests, authenticates users, and coordinates the agent. Sensitive actions pass through a wallet service where transactions can be prepared, simulated, signed, and submitted safely. A policy engine and database preserve state, enforce limits, and create an audit trail for every important action. Safe agents treat every on-chain request as a controlled workflow, not a direct command. The system first translates the user's language into a structured intent. Then it gathers context, such as wallet state, market data, chain conditions, and policy rules. Before anything is signed, the plan is checked against limits, allow lists, and simulations. If the risk is acceptable, the user approves execution. Finally, the system records the transaction hash and outcome for auditability. The orchestration service acts as the agent's control plane. It decides when to call the model, which tools are allowed, how planning loops continue, and when to stop. For blockchain actions, the model should never receive raw, unmanaged access. Requests should go through policy-checked services with limits on value, retries, tool calls, and timeouts. Keep orchestration stateless when possible, and store durable conversation, task, and execution state in databases or queues. Wallet signing needs a stricter boundary than normal application logic because one approved transaction can move assets or change permissions. A dedicated service keeps keys out of frontends, prompt context, logs, and agent code. It constructs transactions, simulates them, checks policy, routes approvals, signs in a controlled environment, and then broadcasts. Custody may use user wallets, server wallets, MPC, multisig, or smart accounts. Log intent and outcomes, never secrets. Policy is where agent autonomy becomes operationally safe. Before a transfer, contract call, swap, or vote executes, the request is checked against deterministic rules: who can act, what they can do, where they can do it, and how much value is allowed. Familiar low-risk actions can pass automatically. Unusual destinations or high-value moves require human approval. Every decision is logged, giving teams a trace for debugging, compliance, and post-incident review. Production agents need storage they can trust after crashes, restarts, and delayed confirmations. Keep operational state, such as users, wallets, tasks, and scheduled jobs, separate from conversational memory, which may live in a vector store. For blockchain work, record chain ID, wallet, nonce, transaction hash, status, and confirmations. Also persist prompts, tool calls, policy decisions, and approvals. That audit trail turns agent behavior from a black box into something debuggable and accountable. Blockchain APIs should respond quickly, even when the real work may take minutes or fail temporarily. The request should create a job, place it on a queue, and return. Workers can then monitor events, check confirmations, track DAO proposals, or send alerts outside the request path. Because retries are normal, each job must be idempotent. Store status, errors, retry counts, and timestamps, and route exhausted jobs to a dead letter queue for review. Recurring agent work belongs in a scheduler, not in the model's judgment about when to act. The scheduler runs on a fixed cadence, such as every 5 minutes, hourly, or daily, and enqueues a job for a worker. The worker performs the check, stores results, and records timestamps or checkpoints. This makes retries safe and helps prevent missed or duplicated scans. Use this pattern for chain monitoring, unpaid invoices, governance digests, alerts, and portfolio updates. Webhooks shift deployment from keep checking to react when notified. A blockchain indexer, payment provider, wallet, or infrastructure service sends an event to your endpoint. First, verify the signature, so the agent only trusts authentic messages. Then store the raw event before processing, which makes replay and debugging possible. From there, queue work for a worker. Use event IDs, transaction hashes, and idempotency keys, so duplicates do not trigger repeated agent actions. Treat every secret as production-critical infrastructure, not a convenience string. Environment variables are a useful starting point, but they are not a complete strategy. In real deployments, store API keys, RPC credentials, database passwords, webhook secrets, and wallet keys in a vault or cloud secret manager. Never place them in prompts, logs, front-end code, screenshots, or Git. Restrict each secret's permissions, rotate it regularly, and assume any accidental exposure requires immediate replacement. Mature release pipelines treat each environment as its own security boundary. Development uses disposable secrets. Staging mirrors production on testnets. Production gets the strongest controls, monitoring, and approval gates. Rotate API keys, RPC keys, webhook secrets, and wallet credentials on a schedule, and immediately after compromise or employee exit. Combine that with least privilege, feature flags, canary releases, rollback plans, and monitoring, so releases are controlled, observable, and reversible. Deployment is the bridge from prototype to production. Separate the interface, API, wallet, policy, database, and agent orchestration. Use workers, schedulers, and webhooks for asynchronous blockchain activity, and protect the system with strong secret management. Next, you'll combine these patterns into your autonomous Web3 AI agent capstone.